Hello. So in this video, we are going to be talking about the odd property for functions, usually called odd functions, not in a strange way, but in a symmetry kind of way. So before we jump into the odd property, again, it's helpful to sort of talk about the symmetry. And the particular type of symmetry that we're going to be talking about is rotational symmetry. So rotational symmetry is where we sort of put a pin into the shape and then spin it some amount and get back the shape that we had. So in our case, we're going to be putting a pin in the origin. So this is actually really important, is that for the odd property, we need it to always be in the origin, not where it might actually work, but in the origin. So we'll see what I mean about that in a second. Here, if I take this thing and I spin it 180 degrees, I get back the exact same shape that I started with. So this has rotational symmetry. Specifically, it has rotational symmetry of 180 degrees. So technically speaking, rotational symmetry is any amount of spinning, right? So if you took, for example, a perfect square and you pinned the exact middle, you could spin it 90 degrees and get the same square back. So that would have a 90-degree rotational symmetry. But here, we only want 180-degree rotations, and we only go about the origin. So the odd property, it corresponds specifically to doing 180 degrees about the origin, meaning that if we took the same shape, right? So this is a rotationally symmetric shape, but if we moved it, technically this would still be rotationally symmetric if I put the sort of point that I spun around over here, but that's not the odd property. The odd property requires that we spin it around the origin, and if we do that, well, then we get something else, right? So we can see here it sort of looks almost the same, but now that middle kind of point that was sort of the middle part where it goes through the x-axis, that's now at 1 versus when we sort of started it before, it was at -1, right? So started here, moved over here, okay? So this is the sort of rotational symmetry perspective. The odd property, right, needs to go about the origin, meaning that the pin that we spin around is the origin, and it has to be 180 degrees. All right, so what about the analytic perspective? Why do we care about this kind of symmetry? Again, there's sort of two parts to this. There's the graphing or knowing information, and then there's the way that we actually describe this thing with a definition, which I'll get to in a moment. So similar to when we did even property, or when we will, depending on how you're watching these videos, we can look at half of the graph. So if we had, for example, the right half, and there's nothing special about the right half, we could do this if we had the left half as well, we can use this part to sort of deduce what the other one would, what the other side would be. But it gets a little weird with rotational symmetry because I can't just fold it, right? It's not axial symmetry, which is when we fold it and we sort of line them up. It's rotational, so I need to go sort of 180 degrees around the origin. And a good way of doing that is sort of using a sort of guide line, a 45-degree line, which I'll put in here. And then that way we can sort of see as we go around it what's going to happen. So if I fix a point, then I can trace that point 180 degrees, right? So the first half goes from here up to that line, and then past that line over to here. That is the new value, right? It lands on that part of it. So we can do that with each of these points to get each of these points, okay? So that is how we get the sort of analytic part of that, the missing graph part, right? Is we can take the piece that we have and basically rotate it to get the other side. Now, rotating is sort of a very annoying way of saying what we want to do, right? Because I'm like, if I gave you half a graph and I was like, now just rotate it 180 degrees to get the new half, that would be very obnoxious of me. Sounds like something I might do, but there is a better way. So the better way is to notice that when I did that, when I went from here to here, both signs flip, meaning that if I started at, say, 1, -1, right? So I started at x is 1, y is -1, the new point flips both of those signs. So x goes from 1 to -1, and the y goes from -1 to 1. And this observation, which is sort of hiding in the background here, is why it has to be about the origin. But this observation lets us write down the definition. So the definition in sort of math speak, and I will translate it in a moment, but the definition in math speak, right, If we have a odd function, right, so let f be from r to r, let's say it's a function. We say that f is an odd function if for any x in r, f of x is negative f of negative x, or equivalently, f of negative x is negative f of x. So in human speak, what that means is that if we have a function, normal sort of function, has real numbers, right? You put in numbers, you get out numbers. You're not putting in shapes or car values or some weird thing like that. So numbers to numbers. Then we say that it has the odd property, or it is an odd function, if whenever we put in one of those numbers, it's equivalent, right? If we put in the number and get out a y value, right? So we put in x, get out y, then that is going to be the same thing as if we took the negative on both of those numbers, right? So that's the fact that we can flip back and forth along those things. The sort of more common way to see this, the sort of more analytically useful way of seeing this, is that if we have a negative inside, right, if I want to do f of negative x, that negative sort of magically comes outside. And this is sort of a really rare thing to see. In fact, it's almost never true, which is why odd functions are very special and very useful, is that if we want to know something about a negative inside, I can just pull that negative out and compute the positive version. Much easier, okay? All right, so what do we do? We talked about the odd property, right? So the odd property is sort of tied to this idea of rotational symmetry, where we're rotating specifically 180 degrees around the origin, right? The 0, 0 point. And if we have that sort of odd property, what that tells us is that when we spin around, meaning that if we take the negative of both sides, we also get another point on the graph. And the way we sort of analytically use that in practice is that if we have a f of a negative x value, that's the same as doing f of the positive x value, but with a negative in front, right? So we can sort of take the negative out of that function, right? So instead of f of negative x, it's negative f of x. So this is where it actually is sort of useful in practice, okay? So that is that.